Welcome Unity programmers to this new lesson. In this lesson we will cover the following topics. We start with the introduction. That's what we're doing right now. Then I'll show you how to add a child GameObject to an existing GameObject. And I show how to destroy a GameObject on impact using OnCollisionEnter. And we adjust the speed of the player to make the game more playable. We end the lesson with the outro. This was the introduction. Let's quickly start the lesson. The first thing I want to do before we really get started is remove the debug.log statement that shows the time between each meteor. It was only intended to demonstrate that it works, but is now redundant and even somewhat annoying. Let's open the Game Manager script to remove this statement. I'll make a comment line from this statement, but you can also delete it. Now we can go back to the editor. Our player must represent a cannon or an anti-aircraft gun, but so far it's nothing more than a cube. The minimum we can give the player is a cannon. Select the player and right-click and select three-dimensional object, and then select cylinder. Rename this child object of the player to cannon. Change the scale of the cannon to make it more suitable. X equals 0.2, Y equals 0.5, and Z equals 0.2. And position the cannon on top of the player. Let's test this in play mode. At first glance everything seems to work, but if you look closely you will see that the bullet shoots next to the player when you shoot and move. The bullet doesn't shoot out of the cannon. We need to offset the instantiation of the bullet in the movement script. In the fire bullet function we create a local vector3 variable called offset. We give the variable the value of new vector3 with x equals 0, y equals 1, z equals 0. Now we can add the offset variable to the transform.position to make it start 1 unit higher. We can test this in the editor. It looks a bit better already, but we can even start it a little higher. Let's change the offset to y equals 2. Now the bullet starts at the top of the cannon. If we want to shoot the meteors out of the sky, we have to perform an on-collision check using a rigid body component on the bullet. Let's start by adding a rigid body component to the bullet prefab. Adding a rigid body component to an object will put its motion under the control of Unity's physics engine. If you want to know more about physics, check out Lesson 4, Player Movement in Unity Using Physics. Once the rigid body has been added, we can close the prefab. If we want to work with collisions, we need to check if the game objects have the same position on the z-axis. If that is not the case, they move past each other, even though they appear to touch each other in two-dimensional view. Now we can open the bullet movement script. We start with a comment line so that we know later what this piece of code does. Then we need a function that should be found correctly by autocomplete as soon as you type on collision. A matter of selecting the correct function from the list and pressing enter. In the body of the function we create an if statement to check whether a collision occurs with a meteor. We use the tag of a GameObject to test whether it is equal to enemy. In the editor we give the meteor the tag enemy. With a comment line we indicate what we want to do when the bullet comes into contact with a meteor. We want two things: destroy the meteor and destroy the bullet. But before we start coding this functionality, I first want to check with a debug.log statement whether the collision is detected. If we immediately build all the functionalities and it doesn't work, we have to find out what the problem is. That is why we are building this up step by step. Let's add a tag to the meteor prefab. If you select the enemy, a pull-down menu will appear in the inspector at the top with which you can give a tag to a game object. Since there is no enemy tag available, we select Add Tag. Now you have to open the meteor prefab again to actually add the tag. Now the enemy tag appears in the list. Make sure that you write the tag exactly the same as the tag in the script, and close prefab mode. If all goes well, which can be quite difficult, a message will appear in the console when you hit a meteor. You can see through the rigid body that the bullets are influenced by the meteor after impact. But you won't see any of that anymore because we want to destroy them upon impact. In the bullet movement script we can code how to destroy the bullet and the meteor. We use parameter for destroy of the meteor, collision.GameObject. After all, the bullet to which this script is attached collides with the meteor. For the bullet itself we use GameObject as a parameter. This refers to the GameObject to which this script is attached. We can delete the debug.log or make it a comment line. Let's quickly test whether this works. It is still quite difficult to hit the meteors, but if you succeed, they disappear from the screen just like the bullet. It is useful to make the gameplay a little easier so as not to frustrate the player. I think the game will become easier if we adjust the player speed in the movement script. We create a public float variable called speed. We use the speed variable in the movePlayer function to multiply by the transform.translate statement. And because we want to make the movement frame rate independent, we multiply by time.delta time. Now we can give the speed variable a value in the editor. A speed value of 10 is fine. You'll immediately see that it's a lot easier to shoot the meteors out of the sky. Perhaps a bit too simple, but that is a great assignment for the next lesson. What I also miss is a visual score that is kept. Now you have no idea how many meteors were shot out of the sky or how many were missed. These are all fun things for later lessons. Thanks for watching. In the next lesson, we're going to make a UI to show the score and the remaining lives. Please like and subscribe, so you'll get notified if a new video is uploaded. More people will get this video in their search result when they want to learn Unity game development.